1.1 modeling and equation solving. Alright, so the first problem they say to match the numerical model to the corresponding graphical model and the algebraic model. We're doing this very different than what they do. So they give us a chart of numbers, so an XY chart. And basically, we're just drawing a scatter plot. So, I'm going to count increments of 5, or well, on the X, I'm going to count increments of 1. And then, on the Y, I'm going to go increments of 3. And then basically we're just plotting points. So at 0, it's at 2. At 1, it's at 3. 2, it's at 6. 3, it's at 11. 4 is 18. 5 is 27. If I were to connect these dots, what does this kind of look like?
It's a curve.
It's a curve. Kind of looks like half of a what? Half of a parabola. Let's see. All right, number 6, I'm going to show you how to do these on your calculator as well, just so that the part where finding the line. So if we were to do this one, we would have to find the best fit curve because it's actually a curve. But this next one, it will actually give us a line. So that's why I'm going to show you how to do it, just in case it happens to come up. So you could still set up your scatter plot the same way, just doing it by hand. But I'm going to show you how to do it on the calculator. So Josh, if you already have something in your list, you're going to want to clear them.
Does it say 19?
15. Trying to get this in a spot where it can actually be seen. All right, so you're going to hit stat, edit. Oh gosh, how many numbers do I have in here? Okay, I'll just delete them out. All right, so in your list, you're going to type in an L1. You're going to type the numbers in the X. So you just hit the number and then hit enter. If you have other numbers beyond that, you can like hit delete and delete them out. And then in L2, you're going to put the numbers out of Y. All right, we got that. All right, so then hit second and then y equals, and we're gonna go to a stat plot. We've turned it on, so we just need one of them on. We're looking for this option here that's like the dots that are not connected. You just have to hit enter on it. And then it should auto default to X list and Y list being L1 and L2. Then hit second, quit. Hit Y equals. If you have anything in Y equals, clear it just so that it doesn't cause a problem. And then hit zoom. And stat, I think, is 9. Yeah, zoom stat. And you should get a nice little stat plot there. Okay, so if I ever ask you to do this and you just do it off your calculator, you don't have to put like labels or anything on it. You can just draw what it looks like. Basically, just like that off your calculator screen. All right, let me see. Before you click something, let me check and see. Okay. All right, so hit stat again, and then arrow over to calc, and you're looking for len reg, which is this ax plus b form. Okay, and you're gonna click that. It's gonna ask you for your x list and your y list. So if you don't already have L1 and L2 here, X list, you're gonna hit second stat, and that's gonna bring up the list, and then you just select which one you want. So now I have L1, L2. I don't need to put anything in this frequency list. In the store reg EQ, that's saying to store the equation. So basically, we're asking it to give us the best fit line for this data. So we're asking it basically, if I were to summarize this as a line, what would my equation be? And so it's going to give us that. So if you want to store that, you hit, hold on one second. Alpha, nope, not that one. Nope. There we go. Okay. It's alpha, so the green button, and then F4, so that's the trace button. And then this brings up your Y variables, which are your Y equals. Okay, that's what that brings up. Does everybody have this in? And then hit calculate. And so it doesn't write the equation here for you, but you can take and plug it in. So this tells us that my regression equation would be y equals ax, so 2x plus b is 3. And so then if we go back to y equals, they actually have it written for you. So that's where it stored your equation. If you hit graph again, it draws the best fit line through there. Now in this case, all the points were on the same line. Okay. That won't always be the case. Sometimes they're like all sporadic and off and whatever. And so it's drawing a line between them that would summarize the data the best. So I'm not necessarily going to expect you to be able to do that. I just wanted you to see it. So like Josh will get it in stats a lot more in depth than this. So if y'all end up taking stats in the future, you'll have an intro to it.
You should definitely take stats. The great class.
It's a school of thought. All right. 12. All right, this one you're going to need your book open for because you won't be able to answer the question otherwise. It's on page 75. So these say refer to the data in table 1.6 below showing the percentages of the female and male populations in the United States employed in the civilian workforce in the selected years from 1954 to 2004. And so it shows male and female in each year. And so just like reading that, we could make scatter plots and look at it, blah, blah, blah. But according to the numerical model, what has been the trend in males joining the workforce since 1954? So basically, if you look at that chart about males from 1954 to 2004, what do you notice about it?
It's decreasing.
Yep. It's decreasing every year, except there was a slight increase from 1994 to 1999. It just went up slightly and then it went back down. And then part B, in what 5-year interval did the percentage of men who were employed change the most? So when did you see the biggest change? Like what year span?
69 to 74.
I'm seeing like
So what's the difference in those?
or 79 to 84, which is 3.3.
Okay. So 79 to 84 was 3.3. What was 69 to 74 that Riley said?
3.2.
Okay. So then 79 to 84 is slightly larger then, right?
Yeah.
So 79 to 84 would be the biggest increase, or change, I should say. It's not really an increase. All right, we're probably gonna pause there. Tomorrow we'll do a cake problem, and then that's like the pizza problem. So I'll make you hungry again. And then we have a few problems that are solving the equation algebraically. And so there's just some different ways to do that. Quadratic formula, solving by square roots, or just like the zero product property. So we'll look at that, and then you should have time tomorrow to do most of the notes. But the 1.2 notes are posted if you are bored tonight and want to get started on them since they're super long. You could. We probably have about a page worth of examples left just for spacing in your book if you care about that.